My name is Jerry Hargrove. Let's see, where am I? I'm a cloud architect and evangelist at a company called Lucidchart. And my role there is to go out and I do a lot of research and experimentation and talking about cloud technologies, and specifically AWS. My background, as you can see, my Twitter handle is AWS Geek, so I've been working in AWS as an employee at AWS, as a developer, as a solutions architect, as a customer of AWS, and as a partner of AWS. So I have a background in AWS. And Lucidchart pays me to go out and talk about cloud technologies and wear our Lucidchart shirt. So if anybody is on Twitter and you take a picture of this today, mention me so that they know I'm actually out doing my job, traveling around the country. So today I'm going to talk about building a machine learning enabled bot on AWS. And this is based on some experimentation and projects that I worked on earlier this year, and I'm going to share with you sort of my experience with that and my journey through sort of learning about machine learning on AWS. This isn't going to be a tutorial really on machine learning. How many of you here work in data analytics or machine learning already? So yeah, you guys, you'll roll your eyes today at some of the things I'll probably say about machine learning. Y'all are probably the experts in this space. I come at it from an AWS perspective, from a practical application. So I'm not going to talk in depth about machine learning. I'm going to talk about building this. So let me ask you a question. How many of you know what aircraft that is? I just saw one landing out here this morning at Dulles. What? A380. So how did you know that was an A380? Double decker. Okay. What else? What are the other cues? It's huge. Yeah. It's big. That is that's an A380 landing in Munich. But yeah, you can see double decker. It's got 4 engines, so 2 on each side. Yeah, it's huge. Even the carrier Emirates, they have a bunch of A380s. So. It's easy for us to see and pick out visual cues and identifiers that tell us what type of aircraft this is. But if in the absence of AI and machine learning, how would you write an application or a code to do this? I mean, if you think back 10 years ago and not even thinking about a problem this complex, we would probably build some sort of rules-based system, right? We do a lot of ifs and thens and elses, and I still can't imagine how I would build a system to do this. And so I set off earlier this year. Part of my role is traveling, and so I get to sit in a lot of airports, I get to see a lot of aircraft, and this seemed like a good way for me to explore machine learning on AWS, and in particular, sort of visualization of data. And so I built this is a Twitter bot that's on Twitter right now. It's called Aircraft ML. If you go to Aircraft ML on Twitter and you tweet an image of an aircraft to it, it will tell you what type of aircraft that is. So it's mainly been trained on modern commercial aircraft like A380s and 737s. If you send it a picture of an old or a military aircraft, it won't be able to tell you what it is. But so this talk today is really based on, it's a tutorial around building a system that is similar to this. Now, if you built this itself, this is what it would look like on AWS. How many of you are AWS users? So that's a good chunk of you. Half of you are familiar or at least use AWS. So that system that I just showed is this right here. And I won't spend a whole lot of time talking about it, but just to go through some of the major parts. So how that system works on Twitter is someone tweets to Aircraft ML and gives it a picture. That tweet is actually sent to number 2 here, API Gateway on AWS. We'll talk a little bit more about that. So it's an HTTP endpoint, sort of the public interface to AWS. That in turn invokes a Lambda function, a serverless function, number 3, that takes that request from Twitter, parses the JSON, puts that request into an SQS queue number 4. That act triggers another Lambda function, which takes that request out of the queue number 5, and then that's where it actually starts working on the image. So it takes that image, uses number 6, another Lambda function. That these Lambda functions all have machine learning models that they use to process images with. This one here actually looks at the image and says, is there an aircraft in this image at all, or are there multiple? If there are, then it takes that image, it crops it, maybe there are multiples of them, and sends each one of those to number 7, the actual aircraft classifier itself, which says, okay, that looks like a 737, that looks like an A380. And then I also use number 8 and 11 to do sort of tail number detection. So detecting text in an image, using regular expressions to determine whether it looked like a tail number, and then looking that tail number in a database online. So that was all aircraft ML. We're not going to build this today. We don't have that much time. I was talking earlier about how long it actually took me to build that initial application, sort of as a side project. Probably took 3 or 4 months just playing around with it, experimenting with it, and learning the services. Now we could build it in just a couple of hours, but it does take some time to just learn about the services and figure out what they can do and stitch it all together. So what this tutorial today is going to do is focus really on sort of this main path through here, and that is the sort of the endpoint, which is Twitter. We're going to use Slack instead. We're going to use number 2, API gateway and some Lambda functions. And ultimately, we're going to build this right here. We have just enough time for me to walk through this and build this. We're going to use Slack as the public interface. We're going to use API gateway as a public HTTP interface into an AWS system, a couple of Lambda functions to actually execute code, and then we're going to use Amazon SageMaker as the machine learning backend for this system, and S3 as well to store the model. So here's how we're going to do it. Real quickly, I've broken this up into 4 labs. I'll tell you a little bit more about these in just a few minutes. The first one is going to be setting up SageMaker. Anybody here used SageMaker before? All right, so we've got a couple people who have used it. I'll talk about it. Second lab is building sort of this private interface. We'll set up a Lambda function then that allows us to execute or exercise the machine learning model created with SageMaker. Third, we'll set up a public interface using API gateway and another Lambda function. And finally, we'll create a Slack bot that you can actually go into a Slack workspace and call out a bot and say, hey, tell me what kind of aircraft this is. So before we get started, you'll get the most out of this if you have some experience on AWS. I'm not going to go into great detail about Amazon Web Services and the particular services that we'll talk about today. I'll mention them high level, what they're used for, but you'll want to go off and dig into them some more to get the most out of this. Also, like I mentioned, most of you or many of you have more experience with AI and machine learning than I do. I approach this from a beginner's perspective with relatively none. And so I may say some things that, again, you'll probably roll your eyes and think, he really doesn't know what he's talking about. That's true when it comes to machine learning and AI. Definitely not. So you'll get the most out of this if you have some experience with AI and machine learning on your own. If you want to follow along, everything that I'm going to be doing today, so looking at the bottom there, is in a GitHub repo. This is a tutorial that I've built. I'm actually going to use it to go through this today. If you have an AWS account and you want to go through this with me today as we go along, you're more than welcome to do that. You'll also need a Slack workspace ultimately. That only takes a few seconds to set up if you're online. If you do want to play around with this, send me an email at this email address, jerry@awsgeek.com, and I'll send you an AWS credit code, which will you can apply it to your AWS account, and I believe it's either $50 or $100 worth of AWS credits, which is a nice chunk to play around with. For building this system here today, just in the 90 minutes that we have, we probably maybe $10 or less of AWS resources, assuming you spin them up and spin them back down when we're done. So make sure you do that. All right, so let's go ahead and get started. So what I'm going to do is I'm going to walk through this, and I'll stop in between each one of these labs to see if there are any questions, to see where we're at, and see if there's anything else you'd like to know. We'll do the first two, and then we'll take maybe a 5-minute break and do some more questions, and then we'll finish up with the last two. So lab 1, this first section is building the actual classifier itself, and so that's using Amazon SageMaker and S3. So for those of you who haven't used SageMaker before, so SageMaker gives you the ability to build machine learning models, to train them, and then to deploy them, and to do so at scale. So as if you were going to build a production system that you wanted to use these machine learning models in. So it will actually orchestrate training of machine learning models. It will facilitate building endpoints and deploying machine learning models so that you can use them, execute them through HTTP endpoints. And it will manage scaling that out so you can build elastic systems that will scale to your needs. Under the hood, it's really just it provides you with a Jupyter notebook and a shell around machine learning frameworks like MXNet or TensorFlow or other ones that are out there. So really, for someone like me who doesn't know a whole lot about those underlying frameworks, it really just it provides you with access to the knobs and the buttons that allows you to experiment with them without having to get into all the gory details of starting up an EC2 instance, installing one of these frameworks, configuring it, running it yourself. So if you were to build a machine learning model out at scale and you wanted to build a cluster of GPU instances to actually train your model, SageMaker will help do that for you instead of you having to do that yourself. So for someone like me who is new to machine learning, this is a great way or a great introduction to it. So for this model that we're going to build today, so what we're going to build is a machine learning model that will take as input an image that includes an aircraft in it, and as output provide you with the type of aircraft. And specifically today, these labels aren't correct here, but we're going to build a model that will identify one of 3 aircraft, a 747, an A320, and one other aircraft. And so we're going to use SageMaker to build this model that takes those inputs, trains a model, and then allows us then to perform some prediction on it once that model is created. So we're going to put in an unlabeled image that it hasn't seen before, and hopefully it outputs the right type of aircraft. How many of you have built machine learning systems like this? So more object detection, image classification, image processing. Okay, so we've got a couple. How about others who have built machine learning systems around data analysis? So yeah, I was at a Google conference not too long ago, and they mentioned that 95% of their machine learning work at Google is not, this is sort of, for me, this is sort of the sexy part of machine learning where I can use images and visualize it, but 95% of what they do is actually just processing that data, click data, e-commerce data, et cetera. So with that, I'm going to jump into this. So I'm using this GitHub repo that I mentioned. Everything that I'm going to talk about is here. I'm going to walk through this tutorial just like you might, and so you can see how easy it is to do this. I'm going to build this inside of an hour and a half. And let me know, I saw someone stand up. No, that's at 150%, so we'll leave it there. So I'm going to use these tutorials. I'm going to walk through it. The couple prerequisites, again, you're going to need an AWS account if you want to follow along, and a Slack account. One thing to make note of here is that for this tutorial, when you do this, make sure that you create all of your AWS resources in the same region. And make sure that all of the services that we're going to use are in that region. The only one that you might have to question is SageMaker, whether it's available in all AWS regions, and API Gateway for that matter. But for the most part, they're all available. I'm gonna use a single region I think, Ohio to do this today, just because I don't have any AWS resources there, and it'll be easy for me to clean up afterward. So I'm just going to jump into this, and we'll get started. So to train an aircraft classifier, this is lab 1. The first thing we need is an S3 bucket. And an S3 bucket, we'll use that to store the actual resulting model that's built, and we'll use it to store the inputs to this system. So we're going to go to S3 and make sure that's the right size. Yep. And I'm going to create a bucket. I'm going to call it, here, I've already got one already, AWS Geek ML Classify. And the region here is US East Ohio. Again, I'm going to put all of my resources there. So I'm going to create a bucket in US East Ohio. Actually, I'm going to copy that name because I'm going to need it in just a second. And I'm just going to click on create. That's all you have to do. Now we have an object store in Ohio that we can use to store these objects. That's the only setup we need here. Now we're actually going to go and create a SageMaker notebook. Everybody familiar with Jupyter notebooks, or many of you are. So really, that's the first thing we're going to do, is we're going to spin up a SageMaker notebook instance, and that's what we're going to use to ultimately to train this model. So I've got some convenient links here that you can use when you're doing this. Open the link. Make sure that we're in the same region as our S3 bucket, and we're going to create a notebook instance. Now, for today's purposes, I'm going to call everything ML Classify. And there, if you follow along in here, the only thing, we're going to use all of the defaults except for here, IAM role. We're going to create a new role. So identity and access management allows you to dictate what permissions this Lambda, or this, what permissions SageMaker has. And just in general, other services within AWS. And specifically here today for SageMaker, what we're creating an IAM role that allows SageMaker to access our S3 bucket. And that's exactly what this is doing, and why I copied that S3 bucket name. This is going to create an IAM role that gives SageMaker permission to read and write from that bucket that I just created. That's all it does. So I'm going to create that role, and then go back to the SageMaker console here. Everything else can remain default. We're not going to use a VPC, no lifecycle configuration. The volume size here is sufficient, 5 gigabytes. Really, we just need to be worried about how much data we're going to be pulling down into the notebook and what it's going to be processing locally. And this is sufficient. So we'll create a notebook instance here. Whoops. That is because I didn't clean up last night. All right, so I'm going to create ML Classify 2. And I'm going to use the same execution role here, so I'm just going to create that. And this will take just a minute. So back behind the scenes, what's happening is AWS is actually spinning up a notebook instance for us. And like if you were spinning up an EC2 instance, this might take a minute for that to happen. So we're just going to sit here and think about this. So the next steps after this, once we've got this notebook instance up, we're going to go download the actual notebook that I have created, and then we're going to execute some of the code in this notebook. And we'll walk through each of the steps. This is probably the longest portion of this, is actually creating the notebook and then training the model. As you'll see as we get further along into this, the model that I'm creating, I've provided all the sample images for us, and we're only going to do a couple of epochs on it so that it doesn't take too long to actually train it. Obviously, if we were in a production environment, then this would take longer and we'd spend a lot more time on it. But we only have an hour and a half to do this today, so we'll take what we can get. And this should just take a minute here. Of course, it always takes longer when you're staring at it. There we go. We're getting there. Nope, not yet. So one of the things, we'll come back to this a little bit later. So this provides, SageMaker provides us sort of this view into this machine learning environment. And we'll come back to this in a few minutes. But we'll be able to see when we kick off training, we'll be able to look at the logs associated with training as though we were looking at the logs on an EC2 instances that was running this training. So we'll come back to this console a little bit later on once this kicks off and we can actually start using it. So now it's in service. And I'll go back to the actual tutorial here so that we're following along. We've created the IAM role. Again, all of these steps, we're following these exactly. We're going to load we're going to click on open to open the Jupyter Notebook. And then I've created a notebook here. We're going to copy the link to that. This is hosted on an S3 in an S3 bucket. And we're going to load that into our Jupyter Notebook. So if we go back to, let me make sure this is zoomed. There we go, a little bit bigger. Hopefully everybody can see that. I'm just going to upload that file. There. And it's going to download it from S3 and then upload. And it tries to rename it here, so I just clean that up. And now we have this notebook that's ready for us. And we click on it, we can go into it and start executing some of the code. So most of the code that you're going to see today is Python. I'm assuming everybody here is familiar with Python, so we won't talk a whole lot about it. But once we get into this, we're going to start training our model once we get the notebook up and running here. So a couple of things I'm going to do here is, since we're actually going to be doing training, I'm going to start executing these, and then we'll come back and talk to them. But so we have these cells inside of this notebook that we're going to be executing. I think there are 4 of them altogether. The one thing we have to do is we need to specify the S3 bucket that we're using. And so this is AWS Geek ML Classify, just to make sure. Where is it? There it is right there. So here's that bucket. Nothing in it right now. So I'm going to change that name here. That's really the only change that you have to make to this notebook, and then I'm going to execute it, and then we'll talk about it. So I'm going to run it. And then we'll see, we'll know that it's running. It's going to output some text. But really all this first cell is doing is it's copying these training files down from my S3 bucket. So there are 2 files there. So I've already gone out and collected, there's about 1,500 images of these 3 different types of aircraft, and I've packaged them up and separated them out. There are 2 files. 95% of the images are in the training file, and the other 5% are in the validation file. So when ML Classify, or when SageMaker builds the model, it's going to train with the training images, and then it'll use the validation images. Question?
So on your images, you didn't have to do any other pre-processing?
So,
set the sizes or anything like that?
no, they are, no, so I didn't do any pre-processing on them. Now, there are, aircraft turns out to be a pretty easy model to build, because there are aviation enthusiast sites out on the web where they have done all the hard work of taking the pictures and labeling them and categorizing them and making sure that they're high enough quality. And so I didn't do a lot of that work other than just scraping some images off of some websites here. But there's a little bit of pre-processing, and you'll see when the model is set up, and I'll talk about that.
What is your data structure like? Is this just a folder of JPEGs with?
Yeah, this is somebody else may know this file format a little bit better. It's a rec file format where they take all of the images, you can and compress them all into a single file. So it's I don't think it's anything really super special other than a convenient way for this particular model or algorithm to access those images. So that's actually done now. We can see it copied these 2 files down. Now cell 2 is where, I'll grab your question in just a second. I'll start this. So I'm actually going to run this because this, I'm glossing over a lot here. Again, this is the machine learning part of it. So we're actually going to train the model now. And this is going to take about 8 minutes. That's why I started it and kicked it off. But you had a question back in the corner?
Yeah, what libraries can install on SageMaker?
Well, I can tell you the framework. So you can access frameworks like MXNet, TensorFlow, Gluon. There are a whole bunch of common libraries, and they change them or they're updating them all the time. And so frameworks. And there are some other libraries. You have to look at SageMaker specifically to see what's there. So, but you can install whatever you'd like. And then what usually ends up happening is if you really want to get deep and into the weeds with these frameworks, you go back to just doing it on an EC2 instance. So SageMaker provides sort of an abstraction, not really an abstraction, but it hides a lot of the details. So what's happening here, and we'll talk a little bit about this. So I've kicked off this training session, and it's using one of the image classification samples that comes with SageMaker. So if we go back here to the SageMaker console, or the Jupyter Notebook console, there are a bunch of SageMaker examples that come with it. And these are notebooks that you can use and experiment with. This is based on one of these image classification samples that comes with SageMaker. And specifically, this one's doing transfer learning on an existing model and then providing aircraft images so we can get some specific classification for that. But looking at what's actually happening in this cell of code that we just executed, it's setting up a training job. It's configuring some of the hyperparameters associated with creating this model. A couple of interesting ones are we're using 50 layers. You can use 18, I think 34, 50, and there's 100, a couple that are over 100. Number of training samples, 1,425, so that's 475 each for each of the different types of aircraft, and then there are 25 each for validation. There are 3 different classes, so it's going to attempt to classify these into 3 different chunks. Here's where, so I'm doing some things here to specifically make this training session so short so that it finishes in 7 minutes. And I'm like, for example, I'm only using 5 epochs, and that's definitely not enough to get really accurate. When we're all done here, I think validation accuracy of this model is going to be about 85 or 87%, which is not very high. When I built the system that you saw earlier, Aircraft ML on Twitter, instead of 500 images each, I had 10,000 images each, and it ran for, I think, 30 or 50 iterations, and that ended up taking, even then, using a cluster of 3 or 4 P3 8 extra large instances with GPUs, it only took a couple of hours to do that. So I'm doing a lot of things here to shorten that up, and also using a pre-trained model. So we're going to do transfer learning in this case, which means SageMaker is going to use an existing model that's been trained to detect and classify general objects, and then we're going to be building this model on top of that. So it's just peeling the top couple of layers off of that model, and then training our system, our 3 aircraft on top of that. So that makes it a lot quicker. Without that, we couldn't even get to 85 in 5 iterations. We'd probably be down at about 20%. Here, so augmentation type here, we are doing a little bit of processing on these images. So this adds some randomization to the actual input images. So it's cropping each image a little bit different from the next one. It's doing a little bit of transformation, so it might rotate it a few degrees one way or the other. One of the downsides of using images from these aviation enthusiast sites as training material for this model is they're all from the exact same angle. So they're all profile images of aircraft. And so this model is very good at classifying aircraft that you see a profile of, but if you were to go to an airport and take a picture of an aircraft at a gate, sort of from an oblique angle, it's not very good at that. And so this tries to do a little bit of that. So let's look and see where we're at. So we can still see this is in progress. So let's go into SageMaker itself and see what's going on. So we can look at the training jobs. We can see one here is in progress. You can see the other ones that I've done. They all run around 7 minutes. So we can look at this particular job that we created and what's running. Input parameters here. Then you can see the hyperparameters here that we just talked about. There are other ones here that you can change. I just happen to use these. What I really want to get down here to is the monitoring section and logs. So now we can go in and look at the logs associated with this training job. And you'll see here right now, see if I can expand that a little bit. But you can get some idea. Let's scroll down here. You can see it's on Epic 1. Validation accuracy was 87%. And this should roll along pretty quickly now. Actually, that seems like it's moving a little bit slow this morning. So usually what happens, this ends up taking about seven or 8 minutes to this, and it gets around 88% accuracy. So we should be getting 3340. So we're actually getting we're getting closer. So we're up at about 92%. So again, this will get us sort of in the ballpark, and it's enough for the simple examples that I'm going to be doing this morning. Yeah, question?
It is giving me resource limit exceeded error when training the model.
So it could be that you may have to request, so if it's using a P2 extra large, they may have a limitation on the number of GPU-enabled instances that you can create. Or which region did you try it in? Ohio. You could try it with a different instance type, a non-GPU instance. Of course, that's going to make it slower, but that would be my only recommendation. You might have to submit a support case to AWS and ask them to increase your limit on P2 or P3 instances. So we should be getting closer here. Yeah, so validation accuracy, we're actually at about 92% here, which is a little better than normal. If I go back to the console here, actually, if I go back to the console and look at training jobs, we should be getting close to completed. Yes, it was completed. So that model is now done. It's just gone through 5 iterations. Again, real quick example of how you can use this. More time, you'll spend more time actually configuring it and setting it up and learning it, and then kicking off the training job. Once we go back here, now we see that the training job is actually complete. The next step is deploying the model. So I'm going to kick that off before this. Again, will take a few minutes. So what's happening now is this model is being deployed. So AWS SageMaker is taking that model that we created, and we can go back to our S3 bucket now and look at what's in it. We see now here are the 2 files that we copied down when we executed the first cell of the Jupyter notebook. There's also an ML classified directory. If we look in that directory and go down a couple of levels, we'll see this model that we just created right there. So that's the model that it's going to use. So now what it's doing is it's creating an endpoint, a publicly accessible endpoint that you can use or your customers can use to actually exercise this model. And it's doing so here. So it's creating this. It has the endpoint name and the endpoint ARN. We're going to use both of those in the next couple of steps. So to test the model, this again is going to take about 5 minutes because under the hood, SageMaker is actually spinning up an instance and deploying this model and setting it up for us. While we're waiting for this to finish, we can get started. I'm going to jump ahead and skip into the next section, and we'll come back to this. So we'll skip into lab number 2, which is setting up the private interface. So right now we're creating the SageMaker model and we're deploying it. Now we're going to create a Lambda function that wraps it so that we can actually call it from other functions easily through Lambda. So before I roll into that, any questions on the first part? We're going to come back to it and test it once the endpoint is done. But any questions up to this point about SageMaker, I can answer, to the extent I can. Any comments? All right, so we'll go into the second section here, and this is where we start actually writing code and using code to execute this model. So we're going to create a private interface, and we're going to build a Lambda function to do that. How many of you have used Lambda on AWS? What languages? Python, Node, Python? Anybody use other than Python? Okay, so we're going to do the same thing. We're going to create a Lambda function today that executes Python code. If you haven't used Lambda before, this is AWS's serverless offering. So you write the code, AWS handles it, manages it, executes it for you. You don't have to deal with operating systems. You don't pay for EC2 instances that are running 24/7. If your function is only executed once a day for 10 seconds, that's all you pay for. You pay for that 10 seconds that it's executing. There's a cost associated with the amount of memory that you need and the CPU that you use, but that's it. So it can be a very efficient way to execute code on AWS. As a matter of fact, Aircraft ML, which I built, you saw I didn't use SageMaker in Aircraft ML. If you look at the architecture here, there's no SageMaker in it. That's because this is a hobby site. If you run SageMaker, you're paying for SageMaker endpoints and instances 24/7. And my wife looks at this bill every month and wonders why I'm paying for people to classify aircraft. I can't justify SageMaker for a month, but I can justify Lambda. And so for the couple of times a week when someone wants to classify an aircraft, this executes. It costs a couple of pennies. I keep my wife happy. You have a question?
What's a good rule of thumb for choosing between the two for you?
For me, it was all about cost. It really was. At some point, I didn't look to see where the intersection was, where it made more sense. But at some point, it will make sense to potentially switch over to SageMaker. Really, SageMaker is a managed, the SageMaker endpoint is a managed service that manages effectively EC2 instances for you that are running these models, or perhaps containers. Probably more likely that they're running them in containers. But then there's a little bit of a premium for that. There's a premium for Lambda too. So I didn't calculate it, but at some point there is an intersection of those two lines where it would make more sense to do that. So it's probably not a great answer, but it's gonna vary for everybody who does it. I also one other reason that I chose Lambda for this was I received some credits from AWS that didn't include SageMaker, so I got free money from AWS that I could use. But it didn't cover SageMaker, so any of the training that I did on SageMaker had to come out of my own pocket. So ultimately, I ended up doing all of this on EC2 and Lambda. All right, so let's create a Lambda function. Actually, I'll go back and check and see if this is done yet and see if we can test it yet. Nope, not done. So let's get started over here. We're going to create a Lambda function. So we're going to go and we're going to create a Lambda function called mlClassify. We're going to go to the console here, Lambda console, and author from scratch. We're going to call it mlClassify. Python 3.6, it could probably be 2.7, but for now we'll use 3.6. For IAM, for role, we're going to create a custom role. And again, we're creating an identity and access management role for this Lambda function that only gives it permission to execute that SageMaker endpoint. So Here we're going to select create a new IAM role, and all of these instructions step by step are in on GitHub, so if you want to follow along there. We're going to create a new role. I'm going to name it ML classify, just to be consistent so that when I come back and I want to clean up all of this after we're done, I can do that very easily. Click on allow, and then it's going to take you back here to the Lambda creation page. Now it's switched to choose an existing role and ML classify the one that I just created, and create the function. Now, that creation, we didn't actually give it permission to do anything. We just created a role that it's going to use. Now we need to go back in and update that IAM role, and we're going to give it permission to execute that SageMaker endpoint. So this really, all it does is give the Lambda function permission to call the SageMaker invoke endpoint method. So if we go back to the ML classify role that we just created, and I click on add inline policy, and then on the JSON tab, you can do this a couple of ways. Whoops. I'm going to edit this, and let's see if I can expand that so you can see what I just did. So I just pasted in this JSON that's an IAM role. Again, all it gives this function the ability to do is invoke a SageMaker endpoint, but we do need to have the SageMaker endpoint ARN. You could give it ability to execute any SageMaker endpoint ARN. You could just put in this, and it could execute any, but we want to be real specific around about this. So I'm going to go back here, and in this output from our Jupyter Notebook, we see the SageMaker endpoint ARN right there. So I'm going to copy that, and then I'm going to go back to the IAM role, and I'm going to give it just permission to execute this one SageMaker endpoint, or invoke this one endpoint. Review policy, I'm going to give it a name, ML classify, and I'm going to create it. All right, so now we have this IAM role that gives it only permission to invoke a SageMaker endpoint, and as a Lambda function, it also needs permission to write to logs. And so these are the only permissions this function has. So you don't have to worry about, it's probably more of an issue if you were doing this on an EC2 instance of someone compromising the instance and taking advantage of your AWS system. But one thing I noticed when I was back here, I noticed that this endpoint has finished its creation. And so now we have this endpoint in SageMaker out there that is available for testing. So let's go ahead and test it through the Jupyter Notebook just so we can see that it's actually working. So this first cell right here, all it does is download an image from an S3 bucket of mine, and it will display it for us so we can see that we're actually working with a real image. That's an A320 in Munich. And now in the next cell, we're actually going to take that image and we're going to hand it off to SageMaker and have it process that image and then give us back the result, and then we'll print out what that result is. So I'm just going to run this right now, and hopefully this works. Yes, so it's taken that image, it's classified it as an Airbus A320 with very high probability. Well, sort of high probability. But of the three, that was the highest probability. So getting to that point was very simple. It's a very crude model in terms of its ability to really accurately identify aircraft, but it does the job and it demonstrates what you can do with it. This code that is here, this Python code, is almost exactly the same code that we're ultimately going to put into that Lambda function that I just created. So this is really the end of the SageMaker portion of this lab. We've created a model, we've deployed it, now it's ready for us to use. And so we're going to go back to Lambda and build our Lambda function to now execute that. So any questions about SageMaker before I move on? That'll probably be the last time I talk about it, but you can always ask questions later on or catch me after this. So if we go back to lab number 2 now, we're starting to build the Lambda function now. Now we need to go and actually update the Lambda function to call that SageMaker endpoint. If you look at the existing Lambda function now that we just created, this is it, just some boilerplate code. It doesn't do anything. You can execute it and it's not going to do anything for you. So I already have some code here that you can take and copy paste into that function and use directly. The only change that you'll need to make is right here on line 17. We need the endpoint name. So it's not the SageMaker endpoint ARN, it's the SageMaker endpoint name, which we can go back here to our Jupyter notebook and we see it right here, endpoint name. So we're just going to grab this name, go back to the Lambda function, and let me squeeze this down a little bit. And we're going to replace this with that name and click on Save. So if we look at this code, really all it's doing is it's a Lambda function. It's the event that's passed to the Lambda function is now going to contain a URL parameter that corresponds, that points to an image of an aircraft. And then we're going to, once this updates, we're going to extract the bytes from, yeah, perfect timing. Oh, who am I? Who am I today? There we go. So if we look at this function, not now. If we look at this function, really all it's doing is, all right, we're going to do that again. That didn't take. Step back, copy, paste, and then I need to grab the endpoint name again. So I'm just redoing the last couple of steps because it was in the process of logging me out while I was doing that. All right, so Lambda function updated the endpoint name and save it. Really all this Lambda function is doing, as I mentioned, is it's grabbing a URL and downloading the bytes associated with that URL. I want to mention here that this is not production code. I'm not doing any checks or validation of the URLs or the data that's contained in them. This code is just for this example so you can see clearly what's going on. I'm just getting the URL, downloading the actual bytes associated with that image. So I'm not checking to see whether it's an image or not. And then I'm passing those bytes on to SageMaker in this function here, or in this call here, to do classification on. So you can see very clearly what it's doing then. Then I'm parsing the scores. I'm actually going to change this because I'm going to set it to. So what it's going to do then is look and see if the result comes back and it's higher than 85%, then it's going to say, yes, this is an aircraft, and here's the type of aircraft. It's going to do a lookup of these names up here. So I'm going to save this function. And if we go back to the lab now, we're going to create a test for it. So we're going to do effectively the same thing we did in SageMaker, but now through Lambda. So I'm going to create a test event that contains a URL that we can use to test the Lambda function. So if we go up here to the Lambda function and we do the select a test event dropdown and configure test events, I'm going to create an event. I'm just going to paste in that, actually I'm going to do the Airbus A320 because I know that works. A320, oops, don't want a 7. And we'll call it ML classify. And then I'm going to save it or create it. So now what happens is if I click on the test button, it's going to use that event that we just created here, and it's going to execute this Lambda function, and that event is going to contain that JSON that I just pasted in here. So crossing my fingers that this all works right, I click test, it calls that SageMaker endpoint, and it does return, hey, that's an Airbus A320. So this tests the Lambda function. The Lambda function is calling the, where are we at here? The Lambda function is calling the SageMaker endpoint, and the SageMaker endpoint is actually looking at that image, processing it, and determining what kind of aircraft is in it. So we've really gotten to the end of the second part of this, which is creating this private interface using, we've used SageMaker, we've used Lambda, and we've used S3 to this point. It's the actual AWS infrastructure that we're using is pretty simple and straightforward, at least from my perspective. I've used a lot of AWS. It may be a little more difficult than that, but you're probably saying the same thing about machine learning. The machine learning I've kind of glossed over, but you can see that if you're not a machine learning expert, or even if you are, you can pretty easily use SageMaker to build these models. And like I used images because that's easy for me to understand and easy for me to see, and realize the benefits of machine learning fairly quickly. For you, it might be some other data type. You can use SageMaker for more than just images. You can use it for any type of machine learning model creation. So before I go to the second half, we take just 5 minutes. If you have questions or comments, or you want to know more detail, I'm happy to answer any questions you have right now. Go ahead.
I'm new to SageMaker. I wonder, what are the training jobs located? Are they on the S3 or on the training?
So the training jobs themselves are, one of the interesting things is if you go to the SageMaker console, of course everything is timed out now. I'll have to refresh all of these pages. Come on. The training jobs themselves, so the job itself, the configuration is just a configuration file. When you actually train your model, this is happening on a separate training instance. So when we created if you look at, maybe I didn't talk about this directly. When we created the training job here, part of the configuration, you had hyperparameters. I also specified resources to be used for this training job. And what it did was it spun up a single P2 extra large instance, and this is where the training actually occurs. In my case, I only wanted one instance to be used, and I specified a volume size of 50. So I don't know if does that answer your question? This is where the training actually occurs on those instances. And it's interesting to note that these instances are spun up, you do your training on them, and then AWS terminates those instances. So you're not paying for them while training is not actually happening. The notebook instance, on the other hand, you're responsible for starting and stopping it so that you're not paying for it while it's not being used. And the same for the endpoint. If you're not using an endpoint, you can stop it. Go ahead.
So if you didn't use the Lambda function, you would just have the SageMaker notebook open and running, allocating those resources to do the classification?
No. So the Neptune, so right now I've deployed an endpoint that's hosting that model. So that's an AWS resource that I'm paying for, and as long as it's up and running, I have to explicitly go in now and tear it down. And I can call it from this Jupyter model, from this notebook, the Jupyter notebook, or I can call it from a Lambda function, or I could call it from any other code. I could use one of the AWS SDKs, for example, running on-premises systems, and call this code too.
What's the difference between an endpoint and a notebook?
So the endpoint, so the notebook is an interface into building this and executing code associated with building the model. The endpoint itself is a separate AWS resource that's been deployed that actually now hosts that model. So you can, I like to think of using the notebook, the Jupyter notebook, for actually building and configuring and testing, creating the model itself. The endpoint is all about hosting and deploying it.
Is it an EC2 instance?
Under the hood, it's probably an EC2 instance. That's my guess. I don't know the details of it. Any other questions or comments? Were you able to get beyond that? Did you try changing anything? That's my guess, is that there's probably a resource limit depending on your account. If you haven't used SageMaker before, they may have a limit on the number of GPU instances. There are other SageMaker instance types. You can go into SageMaker. Where are we at on time? How much time do we have left?
3 minutes.
Okay, I'm going to roll through this. You can go into SageMaker and you can select non-GPU instance types. So I'll go ahead and get started on the second half of this, which is actually a little bit quicker because we're not dealing with machine learning. So we're going to go into Lab 3 now. And we're going to create a public interface. So we're going to create another Lambda function that really acts as a public interface. So it's going to accept requests from Slack and then hand them off to ML Classify. So we're going to create another Lambda function. And let's see here. Create another Lambda function. We're going to do almost exactly, actually it is the exact same steps as we did before. I'm going to call it MLBot, name it Python, or it's going to use Python 3.6. We're going to create a custom role, go through the same steps as before. Yes. Again, create a new role because we want to give it explicit permissions. We're going to call it MLBot just for consistency's sake. And then go back and create this function. And then we're going to go in and modify the IAM role associated with that Lambda function. And we'll go right here. Go directly to that IAM role. We're going to do the same thing as we did before. We're going to add an inline policy. Go to JSON itself. And just paste this in. You're going to see that we need the ML classify function arm now. So this Lambda function is simply going to call another Lambda function. So we're going to chain these together. So we only want to give it permissions to do exactly that. So I'm going to go to the ML classify function, and I'm just going to grab the ARN associated with it. So this is just an Amazon resource identifier associated with this particular Lambda function. You'll see it for other resources too, like S3 or SNS topics, for example. So we're going to grab that. Let's go back to IAM and paste this in. And now by creating this policy and associating it with that Lambda function, we are now giving it permission to execute just that other Lambda function. And that's it. No more, no less. Now we've created this. Now we have this Lambda function. It has permission to execute another Lambda function. Let's go back and change the code in this Lambda function. And I'll talk about this code in just a second. It'll make sense in just a minute. Whoops, I can't copy and paste. All right. So all of this code is available on GitHub. You can copy and paste it very easily. Lambda function, MLBot that we just created, boilerplate code. I'm going to paste this in. All this code does is, so for the next step, we're going to create a Slack bot. Slack wants to verify an endpoint. All this code does right now is return a correct response to that validation call. And you can see here it parses the event, it looks for a particular event type, and then it returns a particular value. And then Slack, this is all Slack wants to say, yes, this is a good endpoint. I can send subsequent information to it. So we're going to save that. Now, I want to create an API gateway. So an API gateway is going to provide an external endpoint for Slack to call. when it wants to send messages to our bot, and we're going to use API Gateway for that. There are a couple of ways of creating an API Gateway. One is to go through the API Gateway console, configure it, create the endpoint, specify you want it to respond to GET or POST, or what the end URL is. A much easier way of doing that is actually configuring a trigger on the Lambda function. So they've made it super easy to do this in Lambda. If you go into your Lambda function MLBot and you go in the designer section under Add Triggers and select API Gateway and then scroll down, this will do all of that for you. So this is going to create an API Gateway for us. It's going to configure it, and then it's going to give us the URL that we're going to need to provide to Slack. So under API, if I use just create a new API and then specify security as open, what this means is anybody can call that HTTP endpoint. You could also make it more restrictive by providing an API key. Say you hand out an API key to your customers who you want to use this endpoint, or you can use identity and access management. For us, we're just going to leave it open so anybody can call that. And then click on Add. This queues that change up. Once you actually save this function, it will take care of creating that API Gateway endpoint for us. And then it will show down here. There it is right now. That is the interface into our system. We're going to come back to this because I'm going to need it in just a second. We're going to provide that URL to Slack. So now that we've created the API Gateway, let's go to the last part of this section. We're going to come back here and update that Lambda function in just a minute. But for the time being, we want to go ahead and create a Slack workspace and a Slack bot. So if you have Slack at your work, you may not have permissions to do this. I found it's much easier just to create your own Slack workspace. It only takes a few minutes to do it, and then create your own bot. So that's what I'm going to do here. I'm going to create an app, and it will update here in just a second. Hopefully. Come on. There we go. OK, so we're going to create a Slack app. All these URLs are in that document, so real easy to do this. You create an app. I'm going to call it MLBot. I'm going to choose a workspace that I used last week. So I'm going to create this new bot in this workspace, or I'm going to create this new app in this workspace. So again, this is super easy to do on Slack. It would take you a little bit longer to do it on Twitter. I chose Slack just because it's so much easier. And then once you've created the app, you're actually going to create an MLBot user. So there are a couple of ways to interact with Slack. Some of you may be familiar with Slack commands. You can do Slack commands to interact with AWS, or you can use a bot user. I found using a bot user is just much easier because it expects all interaction to be asynchronous. With Slack commands, you actually have to respond right away when you get a request, and then you can do some asynchronous processing after that. This is just much easier to do using a bot user. So we're going to create a bot user in Slack, call it MLBot, use the defaults. We'll show it always as online just so it's easy to find. Click on Add a Bot User. So now we have a bot application and we have a bot user. Next step is to install the app. So we have this app and we have this user, but no one on our Slack workspace can see it until we actually install it. So we just go under Settings, go to Install, and click on Install App to Workspace. They've made this super easy to build these for Slack. So it's real easy to build bots in Slack now. And then we authorize it for our workspace. And you'll see that it gives us some tokens back. We're going to come back and grab these in a couple minutes, because when we respond to Slack from our Lambda function, it wants one of these tokens so it knows who it's talking about. But we'll come back to that. Next thing we're going to do is create an event subscription. Now on Slack, what we want to have happen, if someone mentions MLBot, says, hey MLBot, here's an image, tell me what it is, we want that to be sent to our Lambda function. And so in Slack, the way to do that is to create an event subscription. And with an event subscription, we can specify what events we're listening for, and Slack will send those events to our endpoint. So first we want to enable events. And now it wants this request URL. Here's where you're going to send, here's where Slack is going to send these events. That's where our API gateway endpoint comes into play. So if we go back to our Lambda function and we copy this API gateway endpoint address, as soon as we paste it into this box, Slack is going to send that validation call through our API gateway into our Lambda function. And we'll see that it's validating it, and hopefully we get a green check mark here saying that it's working. So you'll see as soon as I paste it, verifying, verified. So now you can see this indicates that it made that call through API gateway called our Lambda function parsed that request and returned the correct response. That's really it. So pretty straightforward. At this point, we've actually created an event subscription. We've subscribed. We're going to go back here and now subscribe to a bot event. As I mentioned, we want to subscribe to app mentions. So anytime someone says @MLBot image, we'll get that. We'll get that request through our API gateway and Lambda function. So I'm going to save those changes. At this point, I mean, that was super easy. That's all it takes to create a simple bot on Slack. You saw me do it, 5 minutes, and you have a system that you can use for testing and interacting with not just machine learning systems on the back end, but any AWS infrastructure or endpoint. The next step is to go in and update the Lambda function that we created. Right now, that Lambda function does nothing but respond to Slack and says, yes, I am who you think I am. We need to update this so that it actually calls our Lambda function and then returns a response to Slack. So luckily, all that code is right here. It's not very much, and it does exactly what you think it would do. So let's copy this into our Lambda function back here, and then we'll walk through it and we can see what it does. It needs a couple of things. It needs the ML classify function arn. Here it is. I already have it highlighted. So the Lambda function needs, or it has to know who it's going to be, what function it's going to be calling. So I paste that in there. And remember that token I mentioned earlier from Slack? We need that here. So anytime we send a response back to Slack, it's going to contain that token. So we can go back to Slack and go to OAuth and permissions, and we'll find that token right here, bot user OAuth access token. So if you just click on this button here, it will copy it. We go back to our Lambda function and paste it in right there and save it. Oh, yeah, it's going to break, isn't it? Thank you. That one right? Is that it? Got it, thank you. So I'll walk through this real quickly. Again, standard Lambda function, everything is passed in through an event. Right now, this event is going to be the JSON data that Slack passes it. We're going to grab the appropriate data out. So if it sends another URL verification, that code is still there, so it still responds correctly. But we're really looking for this event callback event type. We're going to extract the text out of that event. So you can look, Slack has documented the event. One of the fields is text, which contains all of the text associated with whatever message was sent to MLBot. And then I'm doing a simple comparison. I expect it in a particular format, and I'll show you what that is. But this regular expression is going to be used. I really look for, here's a command, and then there's going to be a URL. So again, not production code. This works in this very specific use case, but it demonstrates how you could do this. So I have a regular expression. It pulls out the command, and then ultimately we're going to use it to look up the Lambda function that we're going to call. So here I extract the text. I do the regular expression search on it, And if I get a match, then I pull out the command and I pull out the URL. And then I take that information and then I call the ML classify function. So I send it the URL and it in turn calls SageMaker model. The SageMaker endpoint does classification on it. We're going to get the results back here, and then we're going to configure and send a message back to Slack. So there's an endpoint, a Slack URL that we're going to send this to. And we're going to send this information along with the text that's returned by the other Lambda function. So super simple, super easy to do. Really the only thing, so we've got at this point, we've finished that. We've actually added the Slack bot. The only thing left to do is actually to send a message to our system from Slack. And so if I go back here, I've got a couple of canned messages. First, let's try one that we know should work. So here's this Airbus A320 aircraft that we've tested before. If I go to Slack now, let's create a new channel let's create a new channel. And now MLBot shows up because I've installed it. So we're going to invite MLBot to this channel. So it will start listening for requests. If you don't do that, you won't get a response. Now if I go into Slack and type in a message like this, so you can see the format. Here's the mention at MLBot. Here's the command classify. We could have made this much simpler. I did it this way because I wanted, if you look at the Lambda function, I want to be able to do different things. So I can send, this way I can do different commands. So I just have to modify this regular expression and update this function lookup, and it will let me do different things. So now I'm telling it classify, and here's the image. So if this works, we should see the image. Yay, so it's displaying that, and we've already got a response back. So this means that it's communicating through API Gateway and Lambda, and yay, MLBot says it's an Airbus A320. So this now demonstrates sort of the end-to-end functionality. So we're taking Slack, we're sending a message to MLBot that's going through API Gateway. API Gateway is handing this off to a Lambda function. Lambda function is calling another Lambda function that's invoking a SageMaker endpoint. So pretty straightforward. We haven't tested it against, so this doesn't always work. If you build this over and over, you'll get different results each time. There's some random aspect to it. And so sometimes you get better models, sometimes you get worse models. Because one of the things that we're doing, at least in my case, is I'm having SageMaker, I mentioned this, apply some rotation, apply some transforms to it. So the images are always going to be a little bit different in my case. So I always get slightly different results. And so it's a little bit of a crapshoot whether this is going to work in front of a bunch of people. But that makes it fun, right? And then I can talk about different things if it doesn't. So let's go back. I've got another, let's see, a Boeing 747. Let's see what it says there. Oh, I spelled it wrong, so it's not going to do that, all right? And you see, if it just silently fails. There's no, you saw the code that I wrote. It doesn't do any error checking. If it doesn't download the image correctly, you'd have to look in the logs, and you'd see it probably blew up when it tried to extract the bytes from a non-existent image. So that one should work. So we see there's a 747 landing in Seattle. Let's see what it calls it. Boeing 747. I have one other.
Are you just parsing strings?
Yeah. I just extract the. Good point. This does nothing. There's actually nothing behind this but a function that pulls the string out. Darn it! There's always someone smarter than me in the audience. How many of you know what a Dornier 328 is? Again, string parsing. You're right. Whoops. Okay, so it worked. Half the time I do this, it it doesn't, and I get incorrect results. But that's because, number one, it's a small model, it's a small training sample. We've trained it. The images that I'm actually using are pretty small too. I think they're 320 by 240, so they're fairly small. And so sometimes it works, sometimes it doesn't. On my larger model that I built with Aircraft ML, it has a pretty high accuracy rate on it. This one, like you saw, 80% validation rate. So that, as far as the tutorial goes, you can walk through all of these steps. If you want to build this yourself, go to this repo and you can extract all of this information out of there. One thing to make sure though, and I'm going to go through some of this right now, is there are a couple of things that are still running in AWS right now. So if we walked away, you would still have some resources that are costing you. One is that SageMaker endpoint. So AWS has spun up resources that are able to respond to those requests, and you're paying for those 24/7. It may be a small amount, but ultimately it adds up. And if you have a partner or a spouse, and this is a hobby project, they will eventually notice it and let you know. That's a true story. So that's running, and you'll want to take that down. Also, that Jupyter Notebook, there's a notebook instance that's running that will incur cost over time. I don't know if I called it out or you noticed, but this SageMaker instance I think was like a T2. Is it like a T2 micro instance size? So cost is pretty minimal, but again, those costs do add up. And so you'll want to go in, and the 5th lab in here is actually about cleaning up. Whoops, I guess I could just do this. Go in and clean up these resources. So SageMaker is there. The Lambda functions themselves, again, you pay for Lambda on demand when it's executing. So while they're sitting idle, there's really no cost associated with them. API gateway resources. I'd have to go look and see what cost is associated with those sitting idle. But if you're not using it, you might as well tear it down. Otherwise, there's a public-facing endpoint that's just sitting out there not doing anything. IAM resources, again, not doing anything, but I like to go in and clean them all up when I'm done. That's why I named them all the same. S3, you've got an S3 bucket out there now that holds this model. There is going to be some ongoing cost associated with that. So again, if you spin this up, play around with it for a couple hours, and then tear it all down, it's probably only a couple of dollars on AWS. Let's see. So to kind of wind down, tear it down, clean up. Again, if you want to try this out, send me an email. You don't necessarily have to include your AWS account number, but send me an email by the end of the conference, and I'll respond with an AWS credit that I believe they're $50 or $100, but in any case, it's way more than enough to play around with this. All of the guides, all of the code that I just walked through fairly quickly are available in this GitHub repo. So try them out and give me any feedback. And with that, if you want to see more, you can follow me on AWS Geek, see some stuff on awsgeek.com. I do these hand-drawn diagrams on my iPad for AWS services that are kind of interesting. And I write on the Lucidchart blog. So with that, I'd like to thank everybody for coming today. I appreciate you coming out this early in the morning. It's like 6 o'clock for me. It's 9 o'clock for you, but that's okay. Appreciate it. And take any questions that you have now. We've got about, 10 minutes? About 10 minutes or so. So if you have any more questions, you want to dive deep on anything, go ahead.
So 2 questions. One, the slides, will you post them? Or?
Yeah, so I'll update these and I'll put them in the GitHub repository too, probably just a PDF of the slides.
And second question, so you have here how to tear it down, but what if you wanted to build it up real quick?
Great question. So I didn't include that here, but everything I did today, I did through the console, through the AWS console. You can do all of this. The model creation is probably a little iffy, but all of the other infrastructure, the Lambda functions, API gateways, endpoints. So you could do it in a couple of steps, but you could do most of this in CloudFormation. So you still have to train the model offline, and then just tell CloudFormation, or specify in CloudFormation that SageMaker endpoint should use this model. So, and then you'd have to do the Slack integration, of course. But all of this could be completely automated, a couple of manual steps. So you may build a system like this and then periodically update the model, for example, very easily. All right. Other question? Yeah, go ahead.
So why are we first creating a private interface and then creating a public interface to call?
You could actually do this in a couple of ways. I went down that path because if we go back to here, it sort of behaves similar to this. And so I was using this as a model where there's a single Lambda function that essentially handles all the requests and then dispatches them. And so this sort of mimicked that. You sort of had this public Lambda function that parsed the input and then dispatched the request to the appropriate handler. So you could actually combine both of those together. There's no real compelling reason to separate them, although it made a nice breaking point, or a point in the tutorial to talk about different things. But yeah, there's no real in this particular application, no real compelling reason to do that. Any other questions? All right, that's it. Thank you all for coming. Appreciate it.